Every single morning, right before you open your eyes, your brain runs through one of the strangest sequences in the entire human body. Muscles that have been frozen for hours suddenly regain control. Your heart rate quietly climbs, your body temperature starts rising again, and somewhere in the dark, your brain flips a switch it has been holding in place all night long. You don't notice any of it happening, but your body is working overtime in the final moments before you wake up.
So what actually happens in those last minutes of sleep? Why does waking up sometimes feel instant and other times feel like crawling out of wet cement? To understand that, we need to look at what your body was doing right before the alarm went off. Let's start with where you probably are when this process begins. Sleep isn't one continuous state. It moves in cycles, roughly 90 minutes each, shifting between light sleep, deep sleep, and REM sleep multiple times throughout the night. By the final cycle before waking, your body has usually shifted away from the deepest stages and spends more time in lighter sleep and REM. This is why the last stretch of sleep before your alarm often feels different from the first hour you fell asleep. Your body is no longer trying to restore itself as intensely. It's beginning to prepare for the transition back to being awake. Most people wake up either during or right after a stage called REM sleep, which stands for rapid eye movement.
This is the stage where most vivid dreaming happens, and it's also one of the strangest states your body enters each night. During REM sleep, your brain is almost as active as it is while you're awake, but your muscles are doing the exact opposite. They're essentially paralyzed. Scientists call this REM atonia, and it exists for a very practical reason. Your brain is generating vivid, sometimes intense dream content, and it doesn't want your body acting those dreams out. So it sends a signal down your spinal cord that temporarily shuts off voluntary muscle movement. You're fully dreaming, and your body simply can't respond. This is actually where things get interesting, because waking up means undoing all of that in a very short window of time. As your final sleep cycle winds down, your brain begins gradually lifting the paralysis. This doesn't happen instantly. It happens in a cascade, one system coming back online after another. Muscle control usually returns first in small, subtle ways. A twitch in your fingers, a slight shift in your leg, small signals testing whether the connection is back before your body attempts anything bigger. At the same time, your heart rate begins to climb.
During deep sleep, your heart rate and blood pressure drop to some of their lowest points of the entire day. But as your body prepares to wake, your nervous system shifts out of its rest and digest mode and back into a more alert state. Your heart beats a little faster, your blood vessels adjust, blood flow increases to your brain and major muscles, essentially preparing your body to move again after hours of stillness.
Your body temperature does something similar. It naturally drops throughout the night, reaching its lowest point in the early morning hours, then begins climbing again as you approach waking. This temperature shift isn't random. It's controlled by your circadian rhythm, an internal clock that regulates nearly every biological process in your body based on roughly a 24-hour cycle.
That rising temperature is one of the signals your brain uses to help time your natural waking moment, even before an alarm clock gets involved. Meanwhile, your brain itself is undergoing a dramatic shift in activity. Right before waking, brainwave patterns transition from the slow, synchronized waves of deep sleep toward faster, more irregular patterns similar to wakefulness. Certain brain regions come back online before others. The areas responsible for basic alertness and sensory processing tend to activate first, which is why you might become aware of sounds or light exposure before you feel fully conscious. Meanwhile, regions responsible for complex reasoning and decision-making, particularly the prefrontal cortex, often take longer to fully engage. This is part of why the first few minutes after waking can feel foggy, even if your eyes are technically open. There's actually a scientific term for that groggy, disoriented feeling. It's called sleep inertia, and it can last anywhere from a few minutes to sometimes over an hour, depending on which sleep stage you were pulled out of. Waking up from deep, slow-wave sleep tends to produce far more sleep inertia than waking up from lighter stages or from REM sleep. This is part of the reason why waking up in the middle of a deep sleep cycle can feel so much harder than waking up naturally near the end of one. Your hormones are shifting too. Melatonin, the hormone largely responsible for signaling sleepiness, begins dropping in the hours before you wake. At the same time, cortisol,
often associated with stress but also playing a major role in alertness, begins rising sharply in the early morning. This natural cortisol increase is sometimes called the cortisol awaken response, and it plays a significant role in giving you that initial burst of energy and alertness shortly after waking, assuming your sleep schedule is relatively consistent. Your eyes are involved in this process as well, and not just because they're opening.
Even before full consciousness returns, your eyes may begin moving beneath closed lids as REM sleep winds down, sometimes continuing briefly into the earliest moments of waking. Some researchers believe this eye movement may be tied to the final processing of dream content as your brain wraps up whatever narrative it was constructing just moments before.
What's particularly strange is how vulnerable this transition period actually is. If you're forcefully woken during deep sleep, especially by something jarring like a loud alarm, your body doesn't get the gradual, layered wake-up sequence it's designed for. Instead, multiple systems are forced to activate all at once. Heart rate spikes suddenly, muscle control returns abruptly, brain activity shifts rapidly instead of gradually. This is part of why sudden, jarring wake-ups can leave you feeling disoriented, irritable, or even briefly confused about where you are, a phenomenon sometimes called sleep drunkenness in more extreme cases.
Compare that to waking up naturally, without an alarm, closer to the end of a sleep cycle. In that scenario, your body has already been quietly preparing for several minutes. Muscle control has been gradually restored, heart rate has already been climbing, cortisol has already started rising. By the time you actually open your eyes, your body has essentially done most of the hard work in advance. This is why natural waking, even at the exact same hour as an alarm-forced waking, so often feels smoother and less disorienting. Maybe that's the real story hiding inside every ordinary morning.
Waking up isn't a single moment. It's the final stretch of a process your body has been carefully managing long before you were aware of it. Muscles slowly coming back online, your heart adjusting its rhythm, your temperature quietly rising, your brain methodically switching systems back on one region at a time. You experience it as instant, but your body has been working in the dark for minutes, sometimes longer, just to hand you something that feels effortless. The moment your eyes open isn't the beginning of your day. It's the final step in something your body started long before you noticed.